Okay, so here we've got a car that starts off stopped, and it speeds up to a speed of 50 miles an hour. Then it slows down until it comes to a complete stop at a light. So the first thing we want to do is we want to draw a rough sketch of the distance as a function of time. So let's do that over here. So let's say we've got this here. So this is the time, and then this is going to be the distance. Okay, so if the car is stopped, then it's going to start right here. It's going to speed up to 50 miles an hour, and then it's going to slow down. Now notice we're going to sketch the distance as a function of time. So you got to be careful because the information that you're being given is speed. So for example, if I were to sketch time and velocity, then I would say, okay, well, it starts at a velocity of 0, it goes up, and then it comes down. Because the velocity goes to 50 miles an hour, so this would be 50, and then it would go back down when it stopped. But here, notice the distance, you reach 50 miles an hour, and then you slow down, but you're still, even when you're slowing down, you're still advancing, so this distance is still going up. So when you're speeding up, notice that you're accelerating. So if you're accelerating, that means your velocity is increasing. In other words, this has to be showing as concave up. Notice how the velocity, or in other words, the slope of the tangent line, if you compare the slope of the tangent line, notice that it's increasing. Okay, but then at one point it starts slowing down, but again the distance is still increasing. So it's going to be concave down. And then when it comes to a complete stop, then time keeps moving, but the distance here doesn't change, so it's just going to be flat. Okay, so think about that. It's you got to be careful that when you are looking, depending on what you're looking at, whether the distance or the velocity. Okay, so now suppose that the equation is f of t equals t minus 3t to the 5th plus 5t cubed, where t represents minutes. Okay, so we want to find the average rate of change from 0 to 1 minute. Okay, so, and then we also want to draw the secant line connecting these 2 points. Okay, so the average rate of change, remember, is average rate of change between 0 and 1 is equal to f of 1 minus f of 0 over 1 minus 0. So f of 1 is going to equal to 1 minus 3 times 1 to the 5th plus 5 times 1 to the 3rd. Okay, so this is equal to 3. Then f of 0 is going to, when you plug in 0, you're just going to get 0 in that case. So here what we've got is 3 minus 0 over 1, which is just equal to 3. So that's the average rate of change. So this is the slope of the secant line between 0 and 1. Now if I draw a little sketch, so I want to actually graph this. Now this isn't exact or anything, but if I graph this guy, it's going to come up, kind of looks like that. And this is 1 and this is 0. So what we're saying is that the slope of this line right here the slope of that line is equal to 3. Okay, so now what we want to do is find the instantaneous rate of change at 30 seconds. Now 30 seconds, that equals to 0.5 minutes. So t is going to equal to 0.5. So to find the instantaneous rate of change, what we're going to do is we'll estimate by finding the average rate of change between let's say 0.5 and 0.6. So this is going to be an estimate, and then later on we'll figure out what it is exactly. So this is going to be f of 0.6 minus f of 0.5 all over 0.6 minus 0.5. And so if I plug in 0.6 into this guy, 1.44672 minus 1.03125 over 0.1. And this is going to equal to 4.15. So this is about 47. The instantaneous rate of change at 0.5. Okay, so we have the displacement in centimeters of a particle moving back and forth along a straight line is given by the function of motion s of t equals 2 sine of pi t plus 3 cosine of pi t, where t is measured in seconds. Find the average velocity from 1 to 2 seconds. Draw the secant line and find the equation. Okay, so to find the average velocity or the average rate of change between 1 and 2, this is going to be, we need to plug in, oh, it's not f, it's s. So we need to plug in s of 2 minus s of 1 over 2 minus 1. Okay, so s of 2 is 2 sine of pi times 2 plus 3 cosine of pi times 2, or let's just write it as 2 pi. Okay, so sine of 2 pi, that's the same as sine of 0, which is 0. So this is 0 plus, then cosine of 2 pi is 1, so this is 3. So s of 2 is equal to 3. Now s of 1 is 2 sine of pi times 1 plus 3 cosine of pi times 1. Sine of pi is 0 again, and then plus 3 times cosine of pi is negative 1. So this is negative 3. So negative 3. Okay, so I've got 3 minus negative 3. Well, that's 6 over 1, or just 6. So 6 is the average velocity. 6, what are the units? Let me put the units here. Here, t is measured in seconds, and, oh, centimeters, right? So centimeters per second. Okay. All right, so that's how fast our little particle is going. Okay, now as far as finding, drawing the graph, I'm just gonna, you can plug this into your graphing calculator, but if you do, you're gonna get something that looks kind of like that, sort of. So this is going to be 1, 2. So the secant line that I just found, this secant line, what I just found is the slope of the secant line. So between 1 and 2. So from here to here, if I draw that, so the slope of that line is equal to 6. Okay, now if I want to find the equation of that line, now that I have the slope, the only thing I need to do is find the y-intercept. So I've got y equals to mx plus b, and so I'll plug in the slope, which is 6, and then I just need to plug in a value for x and y. So here I just need to use a point that I know, and any point will do. So I already have 2 here. I know the value at 2 and at 1. Then you can also do 0, I guess. But let's just do 1. So when x is equal to 1, or sorry, well, in this case it's t, but it doesn't really matter. When this guy's equal to 1, then this guy's equal to -3. So right here we can see it. It's this point right here, -3. Okay, so if I plug that in, I get that b is equal to -9. And that looks about right. I mean, if you kind of follow along this line, it looks like it's going to hit -9. So then the equation is y equals to 6x minus 9. Or you can put t here if you want. It doesn't really matter, just because t is the variable that we're using. Okay, now the next part, it says estimate the instantaneous velocity at 1 second by finding the average rate of change between 1 and 1.001 seconds. So, okay, so we can do that. So I'm basically going to be doing f of 1.001 minus f at 1 all over 1.001 minus 1. Okay. So now if I plug in 1.001 into my function, I would get -3.006268. And then minus f of 1, which I already found up here. Actually, these really should be s's, but no, it doesn't really matter. But when I plug in 1, I get -3. So this is -3.006268 plus 3 all over 0.001. And so what I get with this guy when I do this operation is -6.268. And so that's my estimate for the instantaneous rate of change exactly at 1. So this is the tangent line. So that's what I'm estimating the slope of that line to be.